The other application of GPs that we looked at in finance is the concept of paying off a loan. So we look at the balances, but this time the balance after a payment is made, the balance is reducing. Unlike when you have an investment and you're paying in an amount and you are building on the previous amount. The really, I guess, significant thing that you've got to realise is that in paying off a loan, your final amount the final amount you want is actually zero. You're wanting a zero balance, because if your balance isn't zero, you haven't completely paid your loan off. Now, that works in our favour in maths because we're able to say that the amount has to be zero that we're working towards, and that makes for a nice equation that we can solve. But well before that, we've got to establish that there is a GP actually existing. So we have a few things to define. So we're going to call our repayment M, and obviously then we're looking at the amount owing after a given time. So let's have a look at this example. Sydney takes out a loan of $10,000 to buy a car. She'll pay the loan in 5 years, paying 60 monthly instalments, beginning 1 month after taking out the loan. Interest is charged at 6% per annum, compounded monthly. Calculate her monthly repayment. And again, this is a really common question where you're asked to get the repayment. So we work with this abstract amount. We don't know what it is, so we call it M. We know that the rate per month will be the yearly amount divided by 12, which in this case works out to be a nice decimal. Now, have a think about this. To find the amount owing, it's necessary to consider the interest charged on the previous balance minus the repayment, because that's what happens. So you start off, you take out the loan, and in this case, the loan is $10,000. We're only considering month one. In month one, the amount you will owe is 1.005 due to interest. That just comes from A is P times 1 plus R to the N. So adding on the interest at, 12% per annum, or 0.005% per month. So at the end of 1 month, that's how much is owed. But at the end of a month, a payment is made, hence the minus P. So the amount owing then after 2 months is now this amount times 1.005, because you'll be, in the second month, the interest is only charged on the amount owing. So it's A1 times 1.005, subtract another payment. Now, we now need to substitute for our A1. So our A1 we take from back here. It was 10,000, 1.005, but remember, we've got to subtract the M. So all I've done is I've put at the front the actual expression for A1. Hang on, I think I've done that wrong. Now that's better. You can see the actual amount owing is the A1. So I've replaced A1 in this line here, this line, with that expression from above. We've still got that amount owing, earning interest, but another payment made. So now we're just going to do a little bit of expanding these brackets. So I'm going to expand which ones have I done first? Expanded this 1.005 over the square brackets and removed the square bracket. So that times the 10,000 and 1015 give 10,000 1.005 squared minus m times the 1.005 minus m. Now, still not quite in the format that we wanted. So I've got my 10,000 times 1.005 squared minus, and I'm taking the m out of just those last two. So if I take m out, I can obviously take it out as a common factor. I'll produce 1.005, and taking a minus m out gives me a plus 1. Now, I'm not going to add those two together. I'm not going to add those. This is where our GP will eventually be formed. Now let's move on and see what's happening after the third month. So the amount owing after the third month is this amount that is owed, sitting here, and interest is going to be charged on that at 1.005 for the month, but a payment will be made at the end. So now we're going to replace this A2 with the highlighted pink expression. So putting in my 10,000 1.005 squared minus m times 1.005 plus 1 in this spot, then leaves me with this 1.005 and subtract an m. Now, I go through the same process as I did before, where I'm going to expand this 1.05 into here. So first bit stays the same, 10,000 1.005 cubed minus m times. I'm going to leave the m out and just multiply by that. So you get 1.005 squared plus then just one lot of them, and still subtract m, and then, as I did previously, I'll take the m out of these two terms. Taking the m out, you can see I've got this 1.005 squared plus 1.005 plus 1, plus because I've taken minus m out, and 1. Now at this stage it's a good idea to stop and see if you can see any pattern forming. The things I would draw your attention to are 3 months and a 3 sitting here, and the fact that we've got 3 terms here. This is the unknown. The m is obviously the unknown. The 10,000 was the amount borrowed. This is your 1 plus r, and like I said, that is your payment. So what's going on? After 3 months, it's 10,000 times 1 plus r to the 3 minus some payment. 3 terms of a GP form in the form of 1 plus 1.05 plus 1.005 squared. So while there are 3 terms, this is really your n minus 1. Now, it says there this pattern continues for 4, 5, 6, etc., all the way to A60. Now, let's have a look at what that would look like. So it would be still 10,000, 1.005 to the 60, the amount owing, minus m times, and I've just reversed these, and you could see that it would go so the indices, the maximum index here was a 2 after 3 months, and so this would go to 59. That there are 60 terms there, but the power goes to 59. Now, what do we know about so this is our expression for the amount after 60 payments. But what do we know about our amount after 60 payments? We know that the amount after 60 payments has to be 0. We've paid the loan off, or Sydney's paid the loan off. So knowing that this expression here is actually equal to 0 means we're going to take this whole part of the expression to the left-hand side, and you'll get m times this GP is 10,000, 1.00 to the 60. You know that this is a GP, and the sum can be found using sum to n terms of a times r to the n minus 1 over r minus 1. So, to make m the subject back here, you will need to divide, as I have there, divide by the sum of this GP. Now, I'll just pause the video and write up what the sum of this actual GP looks like. So, looking at the GP, A is equal to 1, R is equal to 1.005. There are 60 terms. So the sum to n terms is A, which is 1, 1.005 to the 60 minus 1, and R, 1.005 subtract 1, goes back to 0.005. So you can see then that I've taken that and I've put it into this position, because we'd had established back here that we want the m by itself, so we're going to divide both sides by the sum of the GP. Dividing by a fraction, you invert and multiply, then going to the calculator, hopefully you can see that, you get this 193.328015, and I think I'm sure you'll be able to get that anyway. And so I've said the payment has to be approximately $193.33. I'll stop the video there and talk about and no, I'll do another example with you in class.